Hello, now we are starting about the session 3 of module 1. So that my course is RF system design and course code 21EC3016. So here we are going to discuss about the topics dimensions and unit of RF amplifiers or RF circuits frequency spectrum. So these two I am combining in one session. So now we are going for the aim of the session is to familiarize you with the basic concept of dimension and units and frequency spectrums. So what are the session designed for? This session is designed for demonstrate EM waves, describe the electric field and magnetic fields, list out the frequency spectrums, describe about phase velocity. So now this session, at the end of this session, we are going to learn, or the outcome is we are ensuring accurate design, analysis and communication within the RF engineering community, understand and work with signals in different fields, enabling the development of technologies that rely on the transmission, processing and analysis of various type of waveforms. So we will start the session. So this session is first I am going for the introduction part. The introduction is the understanding of upper frequency limit beyond which conventional circuit theory can no longer be applied to analyze an electric circuit system. We know that electromagnetic wave propagation in free space in the positive z direction is this one. So I will draw this graph like this. So if the propagation is z direction, then electric field, if this one is z, then it is x and y. We can think about any of the direction you can take. So here it is electric field ex and magnetic field hy, and the direction of propagation is z direction. So for that I am written here beta z. Omega t, omega is the frequency, time always it is, these are the time always. So beta z. E0x is the dimension, that means how much will take. This is the amplitude or magnitude part we can tell of electric field. Like that, this is the electric field magnitude, this is the electric field magnitude, and this is we can take as the magnetic field magnitude. So this is the magnitude part. If electric field and magnetic field are in x and y direction respectively, then the direction of propagation of electromagnetic wave is always with the z direction. And here E0x and H0x are represented as volt per meter or ampere per meter. We can think about volt per meter or ampere per meter. So it is nothing but the current per meter and it is nothing but the voltage per meter. Now if you are thinking about the omega, so here the have angular frequency omega and a propagation constant beta, and the wavelength is lambda, then beta have a relation beta equal to 2 pi by lambda. As per the Maxwell's equation, the ratio between electric and magnetic field component is defined in terms of intrinsic impedance Z0. So it is the intrinsic impedance Z0, and Z0 is always ratio between electric field and magnetic field. So Z0 equal to E by H. If the propagation is in z direction, then it is x and this one is y, we can take. So and the permeability mu and epsilon are material dependent. Permeability is mu equal to mu 0 mu r, permittivity equal to epsilon 0 epsilon r. So and these are the main concept behind the dimension, unit dimension of RF system. I am not telling about the your 12th class unit dimension. So now if you are thinking about the TEM mode, always the electromagnetic fields are in transverse mode. So this transverse mode, you can think that if this is the direction, the wave of propagation is like this. You can see I have given one figure, and here this x field, if it is the electric field, then this is the magnetic field, and they are perpendicular to each other. Okay, and so here TEM mode is the underlying principle of microwave and optical communication. always we are thinking about microwave and optical communication, we are thinking about the TEM wave. Okay, and what is TEM wave? Here the field components are orthogonal to each other and both are orthogonal to the direction of propagation. Then this is known as your TEM. What are both? The both are the electric field and magnetic field. Okay. Now we are thinking about phase velocity. So when we are thinking about a wave, so the wave have the velocity. The velocity is represented as phase velocity. The phase velocity is always omega by beta. So omega is the angular frequency, beta is the phase constant, and it can be, if you have derived, so this formula is 1 by epsilon mu square root. What is mu epsilon? Permittivity, and what is mu? Permeability, and we can write epsilon equal to 1 minute, epsilon is equal to permittivity and mu equal to ability. Okay, and here the normalized wave voltage observing field by volt per meter, and the current is ampere per meter. We can think that. Now, if I am thinking about the frequency spectrum, we are thinking about the extreme low frequency spectrum, very voice frequency spectrum. So, extreme low frequency is from 30 to 300 MHz and wavelength is from 10,000 to 1,000 kilometer. Then voice frequency is from 300 to 3,000 Hz and wavelength is from 1,000 to 100 kilometer. Very low frequency is from 3 to 30 kilohertz and wavelength is from 100 to 10 kilometer. Low frequency is from 3 to 300 kilohertz, like that respective wavelength. Medium frequency is from 300 to 3000 kilohertz. High frequency is from 3 to 30 megahertz. Very high frequency is from 30 to 300 megahertz. Ultra high frequency is from 300 to 3000 megahertz. So super high frequency is 3 to 30 gigahertz. Extreme high frequency is from 30 to 300 gigahertz. Decimillimeter is this much. So we are now working under this one. Nowadays advanced working going on. But we are thinking about this medium high frequency to ultra high frequency in our experiments. Like that, the respective wavelength. So how will we calculate the frequency of the wavelength? So lambda, the wavelength lambda is equal to C by F. So if it is F, it is lambda, then C equal to velocity of light or EM wave. So we can write velocity of light or EM wave. Okay. So like that we are thinking about two spectrums. So now if you are thinking about frequency spectrums, bands, frequency band, then frequency band P band is from 0 to 0.23 to 1 gigahertz, L band 1 to 2 gigahertz, S band 2 to 4 gigahertz, C band 4 to 8 gigahertz, X band 8 to 12.5. X band we are going for microwave band. Q band 12.5 to 18 gigahertz, K band 18 to 26.5 gigahertz, K band 26.5 to 40 gigahertz, millimeter wave 40 to 300 gigahertz, and sub-millimeter wave 300 to 3000 gigahertz. Okay, so this is all about the frequency bands. So here X band is for microwave, C band, K band, Q band we are using for satellite communication, and L band is for GPS system. So these are we are using like this. Now self-assessment questions I have given two. You can think about it. I will give so many questions we will discuss in our class work. These are the terminal questions. Reference I am using this means two references now. Okay. and thank you. This is the end of my third session of course outcome 1. So it is about all about the thing. Thank you.